Hi, welcome at this tutorial about structural bias. Bias is an open source toolbox that stress tests optimization algorithms for structural bias. It fires off 36 statistical tests and a deep learning model in one go, telling you whether bias is present and what kind, center, boundary, etc., then outputs an explainable AI visual for quick diagnosis. Simply run your optimization algorithm a few times on F0, record the best found positions, and bias will tell you if the algorithm is structurally biased or not. So let's get started. To use the bias toolbox, we have several options. 1. We can install the struct bias package using pip. 2. We can clone the source and install the package locally. 3. Or we can simply pull the released Docker image with all the requirements pre-installed. For this tutorial, we will use the Docker image, as it is the most convenient way of using the bias toolbox. The toolbox uses both Python 3 and R. It includes 36 statistical tests of various Python and R packages to provide the most reliable analysis possible about your algorithms. When we start the Docker image, a Jupyter Notebook server will be launched that we can access via localhost port 8888. The notebook contains the bias package, a working R installation with the required R packages installed, and the pre-trained machine learning models for the deep bias extension. The first step is to load the bias package. The next step is to run the algorithm we would like to analyze a number of times. We set the boundaries of the search space and the dimensionality, in this case 30. We run the algorithm 100 times and store the final best position it found in an array. After the runs have completed, we can instantiate the bias toolbox and run the predict function on the array of final samples we just collected. The predict function returns a pandas data frame of the test results that we can further inspect. When we also use the show figure option of the predict function, we get a scatter plot of all final positions for visual inspection and a visualization of the test results, where blue indicates that the test was false, uniform, and green indicates that the test was true, non-uniform. In addition to the regular bias toolbox, which is based on statistical testing, we provide the deep bias extension, which uses a pre-trained neural network to predict the type of structural bias per dimension. This can be accessed from the same bias object using the predict deep method to get the predictions and the explain method to plot the explanations. We can observe that for some dimensions, the neural network predicts with low confidence center bias. We advise to always use the normal statistical tests to determine the presence of structural bias, and the deep bias extension only to get an indication of the class of structural bias predicted. The next example involves the BFGS algorithm, but using two different initialization techniques. The first initializes in the center of the search domain, and the second version initializes uniform at random. Let us first look at the bias results of the BFGS with center initialization. We can clearly see that most statistical tests indicate non-uniformity. The random forest model predicts clusters as the type of structural bias. From a visual inspection, this is clearly center bias. When looking at the bias results of the second configuration, we see that there is no obvious structural bias present. This simple example shows that hyperparameter settings can obviously have a huge impact on structural bias analysis. It is very simple to try this yourself. Just plug in your favorite optimization algorithm and give it a try. Check out our GitHub page and let us know if you are experiencing any issues. Thank you.